Hey, so I have this theory about the nature of time, and the main difference between my theory and the way that we think time runs today, the way that physicists think that time is like an arrow. They call it the arrow of time for various reasons. You have entropy in the universe is always increasing. The universe is always expanding. So these are all things that happen with time. Like any point in time that you look at the universe, if you look at it later, it's going to be bigger. Like there's not a chance that it would be smaller at a later point in time. So these and other sorts of evidence point or seem to indicate that time only goes one way. And if we think about relativity theory, time slows down as you approach the speed of light. Now, my theory is that the time that we experience is actually the net result, the composite of a two alternating, or not alternating, but like time is going forwards and it's going backwards right now at the same time. But the reason why time goes forward is because the forward rate is stronger than the backwards rate. So for instance, like the baseline is that at rest time moves, the forward time rate is exactly double the backwards rate. The backwards rate is exactly half the forward rate when you're centered, at rest. But, and classically, again, time, we just imagine time slowing down as you approach the speed of light. But with this other way of thinking, you can view it as a tug of war, and the forward time vector is actually getting shorter. So I guess, like, if here's the present, and here's the backwards time rate, and here's the forward time rate at rest, and then you approach the speed of light, that forward rate slows down. And then look right there, you can see that it's symmetric. So you'd be being tugged into the past, and you're being tugged into the future. But if you're being tugged into the past and you're being tugged into the future, both at the same rate, then you're not going to go forwards or backwards into the future. They're going to cancel out. You're not going to move. And that is a really interesting thing to think about, because it's consistent with relativity. Like, just on the surface of it, you'd say, oh, well, it doesn't make any sense. Like, forward time could be going forwards and backwards. Like, do you even know about relativity? Like, yes, and it actually is consistent with relativity. It's just, it would be hard to test for this retrograde time motion, but I believe that there are experiments that sort of indicate it. There's a quantum eraser experiment where it's sort of a modification on the double slit experiment, and what they did, or what it does, is it shows that if you look to see like which slit the photon passed through, like after it was already clocked, like it's still going to change whether or not there was an interference pattern on the collector or not. So, and this is 9 nanoseconds after the photon was already released. So it was released, and then they changed the first, like the part where it came out. I'm not exactly sure like what they do with it, but I know that that there's like a tiny little window already experimentally, like a 9 nanosecond window where the future is affecting the past. So if you think about my idea, like what would happen is that for any amount of time that you're interested in, like say you have an event coming up in an hour, theoretically the forward time rate is actually pulling you double that. Like you're actually, your quantum like waveform is going 2 hours out into the future, but the backwards time rate is pulling you back. So it's like you take 2 steps forward and 1 step back. It's the same thing as just taking 1 step forward. But without that backwards time rate, there's nothing to balance the flow of time. You know, like people say time doesn't exist. Some people do, like say that, but you know, it's just that people know that there's more to time, but they can't really explain it. They know that it's not just an arrow going one direction, like it goes one way and it goes back the other way, but the net is set up so that it goes forward. Entropy increases, but locally we can reduce entropy. That's life, but that's, you know, life forms. But yeah, I think that pretty much sums it up. Like it's a feedback mechanism. So things that you think are about to happen, they're actually like happening like right before the present moment that you're experiencing. They're already, all those moments are like flowing back and forth as it's like, because like say here's our present moment and we think we're just going along like that through time, but it's actually going like this, like, but we experience it succinctly, like just as a single moment. Like it doesn't seem like we're fluctuating, because at any given moment, like the moment of actuality is like perfectly balanced out. Each moment you have that net result of the physical state, but yeah, I mean that's pretty much it. I hope that was give somebody out there something to think about. So I guess that's it. Talk to y'all later. Okay, let's get a little bit more specific with it. Like imagine everything that could happen, like every possible physical state of this universe, moment by moment. All of those possible states, you know, based on uncertainty, probability, decisions, you know, decision to do this or decision to do that. You go left, changes the state of the universe. If you choose to go right, it changes the future state of the universe. So, but just imagine like every possible state going forward from the Big Bang to however long the universe is going to last. And then imagine every possible future state traveling from either like positive infinite time, or like the end of the universe, which we pretty much think there's an end of the universe. So I'm in agreement with physicists on that, but like my view of the end of the universe is totally different. But like it gets squished, but that's a completely different story. Super teaser there if you're paying attention, but because I wasn't supposed to say that yet, but the point is that imagine everything coming, all the possible futures going backwards, and all the possible states of the universe going forward. And then imagine yourself in this timeline. So we're just on one track of the time rates. I mean of the like the time frames going forward, and the other ones are going backwards. Okay, imagine a future time rate. I mean a future time frame in which time is going backwards, and it's backing up, and it gets to this point in time in which you got married. And then now let's look at a forward time rate. It's going forward. Now we get to your birth. Okay, well the one going forward in which you were born, it's consistent with the one in which you got married. Now there's this other timeline going forward in which other things happened. You weren't born. Any future in which you got married is obviously contingent on you getting born. Now, you know, you may or may not get married after being born, but you have to be born in order to get married. So, but if we're on a timeline going backwards, a timeline in which, you know, you didn't get married because you were never born, that's not going to be able to actualize with any timeline in which you, with any timeline going forward in which you were born. So they link up. Like, all possible future outcomes are going backwards, and all possible initial states of the universe are traveling forward. And furthermore, another little part of my theory is that that you can travel backwards in time, like literally backwards, but it's got to be to a timeline. It has to be to a slightly different timeline. Like you can go backwards in time, but you have to jump to a different timeline. Otherwise, you get the loop. You get the, you know, your own grandfather paradox. Like, but you can go backwards in time, in my theory, if, say this is a very long distance in deep space that would take light. Say this is a light year. Now, if you jump from point A to point B instantly, if you had technology to teleport from point A to point B instantly, then the way I see it, you would jump backwards 1 year in time, and you would be in a different time frame, a slightly different time frame, but because the time, like, you take the speed of light, you know, the speed of light, it takes a year to get there. But if you're going instantaneously, you know, you're beyond what light can travel. So it seems like you would jump backwards in time. But I mean, literally, people, philosophers and physicists, like, they already talk about how any decision that you make, you know, changes. Not only does it like change what happens in your life, but you know, there's theoretically like another universe in which you made the other decision. You made any number of decisions, or in which the die that you just threw landed on 5, could have landed on 1, 2, 3, 4, or 6 too. And there's a world in which each one of those happened. And they have to carry on as if they did happen. And they do happen. Like, so everything is happening like a wall. Even though we're just experiencing like a single world line going along like this. Like, everything is being actualized. And we just happen to be on one little line of it. Whoa, 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 now we're here, now we're there. But like, literally everything is happening. It's going forwards and backwards. Everything has already happened. Everything that could possibly happen has already happened. And this is consistent with divine infinite infinite manifestation of God and whatever. Like, if I wanted to get into that other part of it, like, but yeah, I just wanted to add the rest of the information onto this talk. Thanks for watching. Thank you.